Hello. Today we are going to revise the chapter States of Matter. So, in this chapter, what will follow is there will be some important questions that are repeating from so many years, because through that question we can revise the topics and theory also. So, our plan is to revise the chapters through the question. So, some important points that you should note before coming into the class that I have written here. So the class will be based on the previous year's questions that are repeating from many years, as I told, and I'll be explaining the theory of the chapter through the problem. So because you once you are doing the theory through the problem, that will explain you what type of questions can come in the exam, because this is not the time to revise whole chapter. This is the time to revise the chapter through the problem, and you'll understand that what type of question can come in the exam. Okay, so I have so many questions, like I have written 10 questions for today class, and then in the coming class we can do some more questions, but for the today class we have some questions from the states of the matter. Okay, so the first question that we are going to do here is factor affecting the rate of evaporation. So the question is factor affecting the rate of evaporation. What factor affects the rate of the evaporation? Affects the rate of evaporation. The rate of evaporation. Okay, now, so if I asked you that question, if you know the solution, first wait for a minute and then write the solution, because once you write by yourself, you'll know that you remember the things or not. If you'll not remember, I'm also doing here. Okay, so the factor that affecting the rate of evaporations are, so factor affecting the rate of evaporations are rate of evaporations are evaporations are first is temperature. You know why temperature affect? When we increase the temperature, the energy of the molecule will this increasement in the energy, what this is telling. So if the kinetic energy of the molecule will increase, it will escape faster, right? So if they will escape faster, it means that the evaporation will increase, right? So first is temperature. So increase in the temperature, increases the kinetic energy of the molecule. Increases the kinetic energy of the molecule. Increases the kinetic energy of the molecule. So increases the kinetic energy of the molecule. What does it mean? So once we are providing the temperature, the molecules that are present there, they are colliding each other. As we are increasing the temperature, kinetic energy increasing, they are colliding, and when they are colliding, they are trying to escape out from the liquid. If they are trying to escape out from the liquid, what does it mean? It means that there is a evaporation will increase, rate of evaporation will increase. So increase in the temperature increases the kinetic energy, and this increasement in the kinetic energy is causing increasement in the rate of evaporation. Okay, so the increasement in the kinetic energy causing the increasement in the rate of the evaporation. Yeah, pencil got discharged. Yeah, so in it increase in the kinetic energy causes increase in rate of evaporation. Rate of evaporation. And I told you why increasing the kinetic energy will increase the rate of evaporation, because the kinetic energy increasing the kinetic energy will increase the motion of the particle, and if the motion of the particle will increase, the evaporation rate of evaporation will increase because the particle will escape fastly. Okay, second point is surface area. Surface area. Okay, so for example, if you have a small surface area, the molecule have a small space, right? So if the space will be more, evaporation will be more, right? So the greater the surface area, means greater the surface area, greater the surface area, greater will be evaporation. Will be evaporation. Evaporation. There is some writing is not that much good, but slowly it will improve. It will increase the rate of evaporation, right? And the third point is humidity. So for example, if the water is humid, means more water vapor is already present, right? Higher humidity means more water vapor is already present in the air. So this will reduce the rate of evaporation. Okay, so humidity, higher humidity will reduce the rate of evaporation. Okay, so and also the lower humidity creates a greater difference in concentration. Means if it will be lower, then concentration difference will be more, and that will allow the particle to evaporate faster. Okay, so from here the question that can come is why we keep the class for more longer time during the rainy season for the drying, and but in the case of when there is no humidity or the humidity is less, they will dry faster, right? So the process by which this is occurring is evaporation. When there is less humidity, the cloth takes more time to get dry, but in the case when humidity is less, the class dry faster. Okay, this question can come in the CBSE for the 1 or 2 marks, right? Okay, the fourth point is wind. Wind is the fourth point. Okay, so when the wind will be faster, then the water evaporate will faster, right? So evaporation will be faster when the wind will be more, right? So faster the wind, the faster will be evaporation. Evaporation. So remember one thing. So whenever you are writing the exam, you should notice one thing. So if they are asking for the 5 marks question, try to write at least 5 points. If you are writing in the points, they will focus more because they have separate points. They will read it out and you'll get the good marks from there. Okay. So for example, fifth point you can write as an example that clouds dry faster on a wind day. So clouds dry faster on a windy day, right? On a windy day. Okay, right. So this was the first question, that what factor affect the rate of evaporation. Now today we are doing the whatever questions that are coming from the factor affecting, we'll complete it today, and some more question also will do. Okay, so second thing is effect of temperature and pressure on the states of matter. What are the effect of what are the effect of effect of temperature and pressure on its on states of matter. Okay, now think once, what are the effect, like what this temperature and pressure do on the states of the matter. Okay, so first thing, like the states of matter, there are three states of the matter: solid, liquid and gas. And they are affected by, or changed by, or they are affected by changing in the temperature and the pressure, right? Now the first point that we'll write here is melting, that is from solid to liquid, right? Now, so when solid is heated, the molecule gains energy, and when the molecule will gain the energy, they start vibrating faster, right? So at certain temperature, the solid turns into the liquid. Okay, so what happened? So when we increase the temperature, or when we heat the solid, when we heat the solid, the molecule gains energy. Okay, if the molecule is gaining energy, so for example, you ate food, and you are living without food, and you are eating food, right? So when you eat the food, you'll get more energy and you'll go for the outside, right? So if you don't have energy, how will you go outside? So when they are getting the energy by heating, the particle start vibrating faster. So the molecule gains energy and start vibrating faster, and start vibrating faster. So they can also ask for the 3 mass question. So what does happen when solid is going to the liquid? Explain the situations, right? So we'll explain that when solid is heated, the molecule gains more energy and start vibrating faster. And when they vibrate faster, at a certain temperature, the solid turns into the liquid. So at certain temperature, the solid change into the liquid. Change into liquid. Okay, remember one thing. So the certain temperature is called as melting point. So this temperature is called as melting point. This temperature is called melting point temperature. Temperature, melting point. And whenever there is a change of the state, the temperature remain constant. Remember these things. Okay, so whenever they are changing the state, the temperature remain constant during the change of the state. Now second thing is that we are going to discuss boiling liquid to gas, that is liquid to gas. Now, so here we can write the example as ice melt into water at 0 degrees Celsius. Ice goes to water, the temperature is 0 degrees Celsius. Okay, now boiling of the liquid. So when liquid boils, what does happen? So remember the same thing. Whenever we are boiling, the liquid getting more energy, right? So if they are getting the energy, the intermolecular forces that is present there in the liquid, the energy breaking that intermolecular forces, right? So when these intermolecular forces are break down, the molecules escapes, right? And it will change into the vapor. So, but changing the liquid to the gas, there is a certain temperature, and there is certain name of that temperature. So the temperature at which this liquid is going to the gas or the liquid is going to the vapor is called the boiling point temperature. Okay, so we can write as, for the heating of the liquid increases the molecular energy. Of liquid increases the molecular energy. Molecular energy. Energy. And at the boiling point, the liquid changes into the vapor. The liquid changes into the vapor. Into vapor. Okay. Now, for example, we can write as a water boils at 100 degrees Celsius to become steam. Example. Water boils at 100 degrees Celsius to become steam. Right? Okay. Now, the third point is condensation. See how many things that we are revising through the questions. Condensation. Gas to liquid. Now, so condensation means converting from the gas to liquid. So, like for example, when we are doing the boiling, we were converting the liquid to gas, right? So in that case, we were providing the energy to break down the intermolecular forces that is present in the liquid. But here, what we are doing? Here we are going from the gas to liquid, right? So if you are going from the gas to liquid, you need to gain. You don't need to gain the energy, right? You don't need to gain the energy to break the bond. So here, what happens when gas molecules lose the energy? They slow down and turn into the liquid, right? So gas molecule lose energy and they slow down and turn into the liquid. They slow down and turn into the liquid. Right? Now the fourth point is freezing. Means liquid to solid. Right? So when liquid is cooled, what happens at that time? So when liquid is cooled, its molecule lose energy and come closer together to form a solid, right? So when what happens? So when liquid is there, when liquid is cooled, its molecule lose energy. And come closer together to form solid. And also this is the necessary condition that the particle should be very closer for the solid state, right? And the example is water freezes into the ice at 0 degrees Celsius. water freezes into ice at 0 degree Celsius. Right? Now come to the fourth point. Okay. Now come to the next question, not the fourth point. We are done with these questions. So there is a question that come in the previous year's board. The question is related to the latent heat. Now, I think you people know about the latent heat. So the question is explain what latent heat is and also differentiate between the latent heat of fusion and the latent heat of vaporization. So question is define latent heat, and differentiate between the latent heat of fusion and latent heat of vaporization, and differentiate between latent heat of fusion, fusion and latent heat of vaporization, heat of vaporization. Right? Okay. Now, what is latent heat? The question is what is latent heat? So latent is the energy that absorbed or released during a phase change without changing the temperature. Okay? So it is a type of energy that is absorbed or released during the phase change without changing the temperature. So it's not a real energy like when, like you can see whenever you are making rice and when we remove the plate and you'll feel the steam. The steam is latent heat. I mean, the heat generally it is called as invisible, like that. Yeah. Okay. So latent heat, type of energy. Latent heat is a type of energy. Heat is type of energy absorbed or released during the phase change. Absorbed or released during the phase change. Right? And during the phase change without changing the temperature. Without changing the temperature. Okay? Now, also they are asking the differentiate between the latent heat of fusion and latent heat of vaporization. So latent heat of fusion is nothing just like a melting. So it is the heat. So latent heat of fusion is the heat required to change solid into the liquid at its melting point without changing the temperature. So I told you also in the previous question that whenever we are changing the state, the temperature remain constant. Okay. So latent heat of fusion. So the heat required to change solid into liquid. So heat required change pencil got disturbed. Yeah. So the heat required to change solid into the liquid. So and this happen at melting point, right? So the change of the solid into the liquid at its melting point without changing the temperature is called the latent heat of fusion, right? And Latent heat of the vaporization is also called the boiling. In this case, the heat required to change the liquid into gas at its boiling point without changing the temperature. Remember, the common thing is without changing the temperature. Whenever there is a change of the state, the temperature will be constant at that time, right? For example, water at 100 degrees Celsius absorbed latent heat of vaporization. Okay? So, latent heat of fusion is the heat required to change solid to liquid at its melting point without changing the temperature. Without changing the temperature. And the latent heat of vaporization sorry, and the latent heat of vaporization is the heat required to change the liquid into the gas. That is heat required to change liquid into gas. At its boiling point. The temperature will not change during this time. At its boiling point. Okay, so we are done with this part. Like we did today 3 questions that are the 5 mark question. So slowly I'll upload 2 or 3 videos from this chapter. So, and the question that I'm doing here will explain all the chapter of states of matter. Okay, so you don't need to worry. After learning from here, you just need to revise the things. You don't need to go through the chapter again. Okay, so whatever important questions that are really needed at that time, I'll do all those questions. Okay, so in the next class we'll again do 5 marks question and 3 marks question and some MCQ also. So let's see you in the next class. Thank you.